Tonight we have a system of equations that involve a quartic and a cubic. And of course, just immediately everybody's going to notice that x equals 0 and c equals 0 would satisfy both of these functions, which of course it's true, but it's trivial and we want to do more than that with our evening, okay? Now we're given that f of x has three distinct real roots, which are also roots of g of x. In other words, the cubic has three distinct roots, and those three distinct roots are also roots of g of x. And we want to find the extra root of g of x, and let's give that a name. We'll call that r sub 4. Now, down here, when you expand out f of x, it has the three distinct roots, r sub 1, r sub 2, r sub 3. When you expand that out, the very last term is minus the product, and that's very well known. You have 1, 2, 3 minus signs, so that minus sign is retained. And so, but remember, this is equal to c. This, as far as the letters I used up here, this is c. And so you would have r sub 1 times r sub 2 times r sub 3 is equal to minus c, right? Now, that's kind of useful because down here we have g of x, which has the three roots specified as also roots of g of x, but we have this additional root r sub 4. Now the minus signs here, when you multiply out, they cancel each other out. So that's why you have the plus sign, which is important right here. And so you see what we get right here, folks. I'll rewrite this piece right over here. You r sub 1, r sub 2, r sub 3 would be minus c. So we have minus c, again replacing the product of the three roots for f of x, all right? Now we still have r sub 4 left right here, which is what we're looking for. We're trying to find r sub 4, but notice that that is equal to 145 divided by 6 times c. And guess what? This works out very nicely. Trivially, you can see we're assuming c is not 0, as we said earlier, so we can divide through by it. And so what we get right here is r sub 4 is equal to minus 145 over 6. So we know that's the other root. And that's all I asked to do on this. I like to keep them short and sweet these days. So that is the answer. Now, you may ask, well, what else could we answer? Well, there's plenty more we could answer here. We could figure out what the value of c is, although that would be tedious if we did g at, right here, we could do g at, what is it, minus 145 over 6? Minus 145 over 6. We could evaluate that. See, and then we would, since that is a 0, right? This is equal to 0. We could actually solve for c, right? We could solve for c right here. We know that when we substitute minus 145 over 6 into here, that this part, in other words, we could eventually solve it. We could figure out what c is from there, since x isn't included right here, right? You see all of this? You could substitute in, the whole thing's equal to 0. So you would get some huge numbers, I think. I think it reduces to relatively small numbers, but you could solve for c. This would help you to solve for c. And once you know c, you could use the rational zero theorem up here to find the others probably, although it might be kind of nasty. You know, but it depends on what c would, if you solve for c, depending on what it was, you might have a short list of potential rational zeros to search. So you see, actually, this is enough information to solve the whole thing, where you could find all the zeros. We already know one of the zeros is minus 145 over 6. It's the extra root of g of x. Okay, but you can figure out what c is from right here. You can substitute c right here. then you just have the rational zero theorem that you could use. Although you could multiply, you'd have to multiply through by 6 or whatever to make it, so you would have integer coefficients, I guess, to figure out what your list of rational zeros were, But anyway, in theory, you could solve. This was enough information. This condition relating these constants was enough to actually solve the whole thing completely. But again, I just ask you to find the missing root, which is minus 145 over 6, folks. So that is all for tonight. The extra root is, let me just write up here again. That extra root is minus 145 over 6. I thought it was kind of an interesting problem. I got this from a problem that was similar, a little bit easier than something published by Dylan Yu and the guys in Euclid's, the guys who do the Euclid's Orchard documents on polynomials, among other things. They're great preparation course content for various types of math competitions. But anyway, that's all. I liked it quite a bit, that you could get so much information from just right here. But this is given up quite a bit to say that the relationship between the constants are related in this fashion. So it's maybe not at first it seems surprising you could do that. Never had to know any of this other stuff to solve the problem, but you would have to know these other constants, of course, to find all the roots. Okay.